All right, now let's move along to question number 3. So we're still doing the same process as we did in the first two. We're going to solve, we're still solving triangles. So let's solve the triangle. Solve the triangle. Triangle with the measures. With the measures. Um, let's have big C equals 66 degrees. Little b equals 33. And little c equals 32. Okay? All right, so first thing we're going to do is draw a sketch of the situation. So let's draw the triangle. 66 degrees is angle C. All right, so let's draw our segments. This is the first segment, this is the second one, and the third segment. Let's call this angle right here angle C. Doesn't really matter how you label it. Angle C, angle B, and angle A. This side is going to be little c, which is 32. This side here is going to be 33. And that's little b. And then this is little a. All right. Angle C is 66 degrees. And we are to solve for our big B, big A, and little a. Now, what kind of triangle is this? What triangular situation are we dealing with here? We're provided with side, side, and angle. Okay? So you can refer to this triangle as SSA or ASS. Whenever you have a situation like this, you are going to use the law of sines because you have a complete pair and an incomplete pair, so you can use the law of sines here. But one thing you want to note about this situation is that this is an ambiguous case. All right? Ambiguous case. What does that mean? It means that when you're solving this triangle, you may have no solutions, no triangular solutions. You can have one triangular solution or two triangular solutions. So you really want to keep that in mind. First thing we can find is angle B. So let's go ahead and find angle B. So to find big B, we're going to use the law of sines. And we're going to go sine big B over little b, since that's what we're looking for, equals the complete pair, sine big C over little c. Okay? Now if we apply this triangle to this formula, we're going to have sine big B over little b, sine little b is 33, equals sine big C is 66, divided by little c, which is 32. Okay? Now let's multiply both sides by 33 to get sine b isolated. So these two cancel out. We have sine b. Sine b is equal to, now let's enter this expression into our calculators. So we're going to have parentheses 33 sine 66 divided by 32. Okay? And then we'll work that out. We get 0.94294. This is good. It doesn't violate the range of sine. So let's write that down. So this sine B is 0.94294. And then to get B, we just take the inverse sine of both sides. So that's going to yield the inverse sine of the result we got before, which is 0.94294. Okay, so angle B is going to be, compute what that is, inverse sine of the result. Insert the answer into the inverse sine function, and we're gonna get 70.4062. Okay, so big B, let's write that down as approximately, let's change that, 70.4062. So big B is approximately 70.4062 degrees. All right, one thing you want to notice, since we're dealing with an ambiguous case here, this angular measure that we just came with is in fact the reference angle. Okay, theta reference. This is a reference angle. There are two angular values of sine that satisfies our triangle. That could be an angle of a triangle and has the sine value of 0.94294. Okay, so what are the two angles that satisfy the measure? Well, since this is a reference angle, we know that the angular values or measures of a triangle can only be positive. So we are going to look at the quadrants where sine is positive and is still within a reasonable value for the angles of a triangle. Okay, so we know that all students take calculus. All students take calculus. These are four quadrants. All right, this is 0, 90, 180. So since any angle in a triangle can be between these values, and sine is positive in these two values, so we have two possible values for sine. The first one is in quadrant 1. That is what theta reference, the first reference angle. So let's mark that. So this is theta. Theta in this case is equal to B. All right. The next one, the next possible value for sine that satisfies this requirement is in quadrant number 2. Okay. How do we graph that? We just basically graph the reference angle. Remember how you graph the reference angle? The terminal side to the closest x-axis. So this is going to be theta. But the angular value for this B that we're going to be looking for is going to be this angle. Let's use a different color. Is going to be this angle right here. Yeah, that's the angular value. Okay, so this at first theta, let's call that theta 1. That's going to be B1. It's going to be theta 1. And then this is going to be the second angular value that satisfies the triangle. Let's call this theta 2. That's going to be 180 minus theta. Okay, 180 degrees minus theta. Let's write that properly. So that's going to be our B2. It's going to be 180 degrees minus theta. Now, why are we subtracting 180 degrees from theta? We know that this is a reference, angle theta reference. And then to find out what this angle is that can be used to construct a triangle, we just subtract theta reference from 180 because a full angle, a linear pair is 180. Okay? So this angular measure right here will be what our B2 is going to be. All right? So let's write down our results. B1 is simply going to be theta, which is 70.4062. Now, what is B2 going to be? B2 is going to be the supplement of this angle. Is going to be 180 minus theta. All right, which is going to be 180 minus this angular value we got. Let's put that in our calculator. So it's going to be 180 minus this angular value. Enter. And that is 109.594. Okay, so 180 minus 70.4062 is approximately going to be 109.594 degrees. Okay, now that we have two angular values for B, what does that mean? Well, it means that our problem has to be split into two cases, okay? Two cases. And we're going to have two triangular solutions. So for case 1, we're going to have B1 equals 70.4062. We're going to solve that completely, and then we'll shift our attention to case number 2. Okay, so let's split it down the center. So let's draw, we have to draw another triangle so we don't confuse ourselves with labeling the inserting the right values into our expressions that we create or our formulas. So let's, well, I'm gonna draw this triangle again. Angle B in this case is less than 90 degrees, so let's draw it accordingly. So something like this, less than 90 degrees. All right, so whatever variables that we find have to have an index of 1. So B1 is going to be 70. Let's put it in green. 70.4062. That's B1. What do we know? We know C angle C. Angle C is 66 degrees. We also know that little c is 32. Now we need to find big A. We're going to call it A1. And we also know that little b is 33. And we also have to find little a1. Okay? So these are the measures for triangle 1 that we need to find. Let's go ahead and solve this triangle completely. Then we'll go to case 2. Alright, so for case 1, what can we find next? Notice we have two angles. We can use the triangle angle sum theorem to find a1. So let's find a1. So to find a1, we're going to have a1 is equal to 180 minus the sum of the two angles, 66 plus 70.4062. So A1 is going to be approximately, plug that into our calculators, it's going to be 180 minus 66 plus 70.4062. Close that. And our answer is going to be 43.5938. Okay, let's write that down. 43.5938. That's our measure for big A1. All right, next thing we have to find is little a1. So to find little a1, we have a lot of complete pairs here. So we can simply use the law of sines. Okay, so we're going to use the law of sines. We're going to use a1 over sine big A1 equals, the complete pair C is a nice one, is what was given to us originally, so that'll be an optimal choice. Little c over sine big C. Okay, so if we apply the measures that we have in this triangle to this formula, we're going to have, that implies that little a1 is what we're looking for over sine a1. Sine a1 is 43.5938 equals, little c is 32 over sine big C, which is 66. Okay, to get a1 isolated, we'll multiply both sides by sine 43.59. Let's write this again. All right, I moved it downwards so we don't have an overlapping situation there. Okay, so to get a1 by itself, you multiply both sides by sine 43.5938 on the left side, and also here sine 43.5938. These cancel out, and you get a1 is approximately, plug that in our calculator, we're going to have 32. Let's put that in parentheses, the numerator in parentheses, sine the answer that we got here, close that, divided by sine 66. And our final answer is going to be 24.1535. Okay, so A1 is 24, approximately 24.1535. Okay, so let's go ahead and organize our answers for the first triangle. So for the first triangle, we have big B1 is approximately 70.4062. Big A1 is approximately 43.5938. And then little a1 is approximately 24.1535. So these are our solutions to the first triangle. All right, now let's shift our attention to the second triangle, case 2. So for case 2, we have big B2 is approximately 109.594. Okay, so let's sketch the triangular situation there. So it's going to look something like this. Like that. And like that. Okay, so now let's populate the measures. You notice that the length of A has changed a little bit. the length of side A has changed, so that's because we're using a different value for our angle B. Okay, so in this case, we're going to have big B2 is going to be 109, sorry, 0.594. And now, whatever measure we are looking for, we have to give them an index of 2. Our big and little c's are given in the problem, so they don't have a 2. We have to find A2. We already know B doesn't change. We didn't have to find that. And we have to find little A2. Okay, so compare these two triangles. You can see how we had A1, A1, and B1 for case 1. For case 2, you have A2, B2, and A2. All right? So we're going to solve this triangle in exactly the same fashion that we did here, but our numbers are just going to change slightly. So let's go ahead and find A2. So we're going to use triangle angle Sum Theorem. A2 is it's not it's an approximation. Because approximately, you add these two and subtract from 180. So 180 minus the sum of these two angles, 109.594 plus 66. Let's plug that into our calculator to find the value of the measure of A2. So we have, let's go ahead and do it, 180 minus, let me see if I can grab the answer I had before. Grab that, plus 66. And the value of A2 is going to be 4.062. 4.4062, okay? So 4.4062. Now what are we going to find next? We're going to look for, what are we going to look for? We're going to look for little a1, little a2, okay? So let's find little a2. Find little a2. Since we have a complete pair and an incomplete pair here, we can use the law of signs as we did over here. So we have a2 over sine a2. And the choices for the complete pair is better to use the c's because they look nice, they're exact. That's what we were provided with in the problem. So that's why I'm going to use the c's, okay? All right, now let's apply this formula to this problem. So we're going to have a2 is what we're looking for over sine a2, sine 4.4062 equals little c, which is 32, over sine big C, which is 66. Now to get a2 isolated, we just simply multiply both sides by sine 4.4062, sine 4.4062. Those to divide out. And then to get a2, we're just going to plug in this expression into our calculator, okay? So let's call that our calculator. Let me change what I had here before. Hold that back. Wait a minute. Let's clear this. Call that back. Enter. And I'm going to change my sine argument into my updated sine value, which is 4.4062. Okay? That gives me a value of 2.69112. So A2 is approximately 2. Let's fix that. Let's bring it back. A2 is approximately 2.69112. All right. Let's see. All right. So that's all we have to find. So let's organize our answers into a nice list. Big B2 is approximately 109.594. Big A2 is approximately 4.4062. Remember on the test, 3 decimal places is sufficient, okay? And then A2 is approximately, let's try that again. A2 is approximately 2.691. All right, so there goes your final answer.